Okay, we just finished our project. We got the EDC bag that I use all the time here, max position bag here, radios, and we have tools that I use to install stuff with. That's our little drill here. It's quite windy up here. Tool bag and the weather module. Give you a look at that. A bit windy up here. Got a lot of zip ties in there, a lot of stuff going on. And the alpha antenna. And here's the view of where we are. It's in 70 degrees right now. The wind is definitely blowing about 25, 30 miles an hour. So we're having a good time. The node's up, working fine. I'm gonna play a little bit of Meshtastic and Meshcore up here just to have a little bit of fun.
Hello and welcome. Today I want to talk about the implementation of sensors into Meshtastic and Meshcore. I've been experimenting lately with the Groveport system on the Wii tracker board. It's the L1 tracker board, and I use those quite a lot for my builds in remote repeater nodes for both Meshtastic and Meshcore. And I find that the integration's pretty straightforward. If not a little bit buggy, but it generally works pretty well with a lot of BME and SHT sensors. So in the video right now, I'm going to show you some B-roll footage and some other footage of how I built a dual Meshcore Meshtastic repeater experiment. I call it the sensor because when you have two radios that close and in the same planar level of proximity, in other words, two antennas very close and not separated vertically, you're going to get a lot of desensing and a lot of interference with each other. It's not an ideal situation, but it's an experiment to test out how well we can use a dual node for both Meshtastic and Meshcore close together on the same power source, with separate batteries, of course, but same solar power source, I should say. You'll see in the build video, I'm going to overlay it with some music, and then we'll talk a little bit about it after that. So if you want to skip ahead to the talking part, you can. But I found a lot of interesting things with building this node and how to make it up. The design is based off of my brother's satellite node. It's a hanging node, or a node designed to be hanged from a tree or some sort of line or some sort of structure, and it has solar panels on 4 different sides. So that's one of my new node builds, and it includes the weather module, the BME 680 in it, and I'm currently testing out different housings for it that will give me the most accurate kind of reading. This is our satellite node. We got panels on all four sides. We got the weather module here, and the little tic-tac box with breather holes, especially on the bottom there. I don't know if you can see that, but it's got a breather hole there so it can let moisture in and out, temperature. We got two antenna ports. This is the Meshcore, and this is the Meshtastic here in the main. We do have a additional port. I did drill a hole a little too wide here, so I used the breather nodule, I forget what they call these things here, and I put a clear cover inside so you can see the solar charging there, the LED light in there, and you can use that port for something else in the future. And we use the paracord hanging method here. Look down here at the grow up, I tied it right to the nuts and the bolt, so it's not going to go anywhere and come loose. So this is our hanging node here, and then it goes up to that and on the wire. This is not the permanent setup, it's just a testing setup right now for the weatherproofing and getting weather telemetry data out here in the front yard. So that is our dual Meshcore Meshtastic node. It's going to fail probably because it's desensing with both transceivers so close to each other, and this antenna width is just not wide enough, and they're also on the same planar level, so it's really not going to be a good station is my guess. Who knows, it might even work, but we're going to have some filtration inside as well, some SAW filters there. Okay, we got everything hooked up, heat shrinked, going into the gland here. These two screws are going to be mounting to the repeater node. There's one here and on the other side here. And on this side, we just put a bunch of extra electrical tape around the other part of the sensor and on the glue, or rather the sealant, so it doesn't necessarily get chipped away. And the clearance is just enough so that it's in the shade in the box here. So we have an option which way we want to mount it. There's the two screw ports which we'll use to attach to the box, and plus this ring behind here, which we got to drill into the main box, the repeater node. And this grow port's just testing out to see if it's still working. It's still verified working. And we have our cover here, and I put a white paper on top there just to blocking the sun coming into it in case we mount it like this. If not, I can take the paper off and mount it upside down so that this will now block the sun. So it just depends on how we want to mount it to the repeater node. But that is the weather sensor temperature model. Again, that's a BME 680. You can kind of see that there in the camera. Okay, I'm gonna go back up for the third time. Put up the weather module, mount beacon in the lot here.
Okay, we installed the partly right now the BME 680 into the Mount Beacon fire tower repeater. Let's open this up and take a look inside. It's very windy up here on a nice warm day. Got that, and let's see if I can get a picture of the telemetry coming in. Maybe not. Probably can't see it on here, but it's there. So we won't be able to do 2 screws into it, but we can do 1 at least. So that'll be nice to do on this. So here's the input. I'm going to put some sealant here. We have sealant here on the actual module. I'm going to seal up one of the holes up here because I can't drill into it and hit the board, unfortunately. So I'll drill in the bottom one at least, so it has a stable point there and I won't move as much. Okay, we finished it. We get the 2 screws there. The breather port here. Got some opening holes here for venting on the bottom. And then one on the side here as well. And the inside we have utilized a lot of the silicone rubber cement. Okay, we got the module installed here, the BME 680. Got a bunch of holes in the bottom. I added some more on the side a little bit here, and also on this side a little breather port at the high point to let out the hot air, but not let in the moisture at the top, so it falls on the sensor. Well, rain specifically, but I don't think it's going to matter much. But we got that. We got the 2 case here, the tool bag I brought up. Trying out a new drill here. It's pretty good. It's very windy here today, but as you can see, the fire tower is pretty high up, and we're looking pretty good. We got some messages back, public, K1 MRE MagSafe from Gatekeeper to his home. Amazing. Roger, Roger, K1 MRE and N2YCH. So, getting them up in the fire tower here. It's a foggy, windy, cold, rainy day, and it's pretty dangerous coming up here with the wet staircase and all that. So testing again, top of fire tower. All right, heard 2 repeats, 4 repeats. Okay, we're getting out pretty good. I don't know how to work Meshcore as well as I do Meshtastic, but let's go ahead and see our map here. So put this back in my pocket before I drop it down the tower here. It's very easy to drop stuff down. So let's turn the camera down for a second so you can see what we're looking at. So we're here on the map. We'll zoom out. Zoom out. There's a repeater by Hosner. This is my server room down there. And then we have a Mount Beacon one over here. Another couple more repeaters in the area, which is cool. And got one up to the north. I don't know if it's going to make us, but we do have Meshtastic Core over here near Danbury. TC Gate repeater here. Let's click on this. See if we can ping out to it 0 hops and see what it does. I probably should hold this out on my hand here. Nope, ping timeout failed. So, not direct, but pretty cool. We can do quite a few things, I guess, with this. I still haven't figured out the whole thing here, how to get through and around. So, contacts, plaza repeater. So where is this thing? 76 kilometers away, 47.39 miles away. So we made a contact there. And also we are at the base of the hill. Apply to him. Roger. So he says same path, almost direct to Monroe CT. We are about 1,300 feet up in the tower. So only heard 1 repeat that time. So he's about 2 hops away, this K1 MRE guy. So I want to see if I can click on him, and nope, doesn't look like it does that. Okay. Let's go back to the map, contact map, and he says he's in Trumbull, which not everybody's going to show up in the map here, but there's Fairfield. Right around here, he's saying he's about there on the map. So we are making a little bit. Oh, plaza repeater. Okay, so that's in Meridian. So that's all the way over. It's about 47 miles away from our location line of sight. So that's pretty good for Meshcore up here in the southern New York area. Southeastern New York, to be specific. They got a whole mesh network over here in Connecticut that we're trying to link up to. So, Alright, we just got a new repeater in. You discovered nodes after a while on the mesh here, and this one's up in Hartford, almost on the border of Massachusetts and Springfield. And let's see what the distance is on that. Let's go back to contacts, and so this one is 63.29 miles away. That is 101.85 kilometers for those of you who don't read mileage, and quite a distance for getting a ping. Let's try to ping it. And channels, public. All right. Yeah, I've wanted to do a drone flight, but crappy conditions this weekend. 3 hops.
getting you 3 hops. New to mesh core. There we go. So there you go. More contacts here. HRT deck. I don't know where he is, but let's look at the map again. Some of the users don't show up. It's more of the repeater stuff here. And we're getting Fairfield. Yeah, we got a couple guys up here. It's a KH base up here. LRB. Yeah, interesting. Let's go to the internet maps. I know there's a way to click on the thing here and look at the internet map here. And home in on our location here. And let's zoom out to see what's been reported on the internet, so that kind of have an idea who's about around here. So here's a more populated map, as you can see, based on internet reporting. So we have people in Litchfield. I don't know if I can click on their names. Nope. I think my hand is just too cold right now. So this is kind of cool. You can see a live packet of all the stuff coming through. The newest stuff at the bottom here, I think. Yeah, 1226 direct trace. Nope. 1 hop. Nope. Float text. Oh yeah, that was me. So you can kind of get a signal path of everything. Huh. Interesting. Discover nearby nodes. Let's do that. Repeater E45. Okay, let's add that. I don't know where that is, but it's coming in pretty darn good. All right, we got Meshcore going up here. It's pretty windy. Mount Beacon Fire Tower. Get the Meshtastic node there. Got the repeater right over there on that birch tree, beyond those clump of trees there. And I'm gonna go ahead and try to send an advert out, flood. So somebody hears me, they hear me. And let's go into chat. I learned how to do this. We go to channels. I've only got a public here, but we're gonna try it out. Testing from Mount Beacon. I spelled fire tower wrong. It's kind of hard to text with just one finger here. Testing, heard 2 repeats. So we're getting out there. Anyone out there? Question mark. So we got two repeats. So we click on the text, right? And it says heard repeats. And we got 1 to HRNB repeater. That's the Hudson River Newburgh repeater. That's down roughly that way. Let's sketch you guys up here so you can see. That's the Newburgh Beacon Bridge. Newburgh's that town right there. So it heard us from up here. That's 9.7. Number F5 is the Mount Beacon repeater, which is the one right on the tree there. So that's kind of cool that you can see where this thing is going through and how far it's getting out. Now, unfortunately, it's not making it to Mount Nimham. At least it didn't hear it come back. So testing. Let's do another one. Testing. Heard 2 repeats, 3 repeats. Okay, so let's click on this. The testing. Oh, my hand's in the way here. Heard repeats. Okay, so it looks like we heard Hoser Mountain. That's about roughly this way, so to speak. So we got in there, and so that's B6. F5 is the Mount Beacon over here. 9.7 is the other repeater. So that's how the heard repeats works in the chat. I didn't know that last time I was up doing this, so learning a bunch of stuff with Meshtastic, Meshcore rather. So it's kind of cool. So it looks like we're getting out to at least 3 repeaters here. So quite an interesting day to play out in Meshcore here. So here on the table we have a variety of different items. I have some modifications I've done to the Weo Tracker housing units, the Weo Tracker L1, not the Pros, but the regulars. These come with 3,000 milliamp hour batteries, and I notice inside of the cases with these is that you can kind of drill holes in the bottom here and on the side to kind of vent it when you put a small sensor in there. Now the sensor I have in the Meshtastic node is a BME 280, so that looks like this little guy here, and this BME 280 does humidity, pressure, and temperature, and it's very small and it's very cost effective. And then I have a Groveport I2C adapter here. That's basically a type of data sending transmission line. So you basically have positive and negative, then you have a clock line and a data send line. But for some of these, you have to get a custom one where it has these individual pin female ends that can poke into the headers on top of your sensor, right? Or if you solder the lines directly to it, you have to solder it in a certain way because it's a little bit reversed. I know that Seed Studios sells a integrated one, or one that's set up properly with the proper pin alignments. You just simply got to swap the white and yellow cables here. So it'll be red, black, yellow, white. And then when it connects to the board, it's really black, red, white, yellow. So you just got to keep that in mind when you're wiring it up. Make sure you got the right correct pins. Basically, you're looking at SCL and SDA. So that's your clock and data lines going in with the I2C protocol. Now, there's other protocols that these can work with. Like, for example, we do have I believe this is an older model. I forget which model this kind of sensor, but it does temperature and I think humidity. But it's a little bit older and it uses a 5-pin, so it's 3.3 volt. These work off of 5 volts, the BME 280 and the BME 680. So the WIO Tracker L1 board can output 5 volts into this little sensor. It doesn't draw that much current from what I can tell. And you can set the resolution or the kind of like gathering data in the app of the Meshtastic to kind of beam out information every hour, 2 hours, half an hour, depends on what you want to do with the module. So it works pretty well. And I decided to drill a couple holes in here and lay this inside the case. It looked like it had enough space in the case to work. However, when you do that modification with the L1 WIO tracker, you will have a little bit more space between your joystick, the 5-way joystick here, and the board, because part of the clip, this portion here, will butt up against the top and push the board away. So you have to undo the screws or tighten it down maybe a little bit more. You have to kind of play around with it. I've had some success with these 5-way joysticks where I put a small toothpick portion, like maybe a millimeter, I cut it to a very fine size, stuck it in the hole so it has extra grip on it, so I can click the joystick left, right, up, and down, and you're able to activate and actuate the joystick. By default, these Meshnology cases aren't that good. In fact, they're horrible. They're not very good at all, especially with the joystick here. And on this side, I did a little bit of modification here by following down the button a little bit, so I'm not always pushing the reset button on these cases. I kind of wish they would make a case that wasn't so easily accessible by pushing the reset button, and a little bit easier implementation with the 5-way joystick on here. So I've done a variety of different things. This one I actually took heat shrink tubing for the 5-way joystick and stuck put it around the side here, put some electrical tape on it, poked it through, and I have a piece of toothpick here, and so it kind of extends the joystick. I'll turn this on right now so you can kind of see how it works. So this is sort of like some modifications you might be able to do with your Meshtastic or Meshcore nodes, but as you can see, I can swipe right and then I can push enter and it will send out. So it's got good tactile feeling basically. And this one didn't mod the reset button on it, but you get the idea. The other modification I did to the WIO Tracker L1s is I added a little bit of a lanyard hold at the very top here where the GPS head is. So there's a way to kind of drill a hole, and I used my small drill to do that and get in there and create a little lanyard loop holder here, which is kind of convenient to hold this upright instead of upside down here. The reason why I didn't want to hold this upside down with the antenna poking me downward is because when you transmit, you really want to have your antenna up pointing towards the sky at least, and not into the ground. If you were in outer space or something, that wouldn't be as much of an issue because it's considered free space technically. But when you're on, terrestrial Earth, you really want to have your antenna ideally pointing towards the sky for maximum transmission. So that's why I did the modifications the way I did them. So again, you can kind of see on the side here, I have a breathing hole and then 2 on the bottom, 2 in the front. I've noticed it generally gets me somewhat of an accurate data read if it's by itself outside. If it's close to my body, it might warm up the material and skew the temperature a little bit. But if I'm hiking, this is on my bag and it's just like kind of hanging, it does get somewhat of a fairly accurate temperature reading. I might drill more holes in there to get more air through and moisture content and all that. But generally the BME 280s are pretty good in here. I think they're a fantastic fit. I might be able to fit a 680 in there if I really want to get some sort of indoor air quality monitoring and just that part of the expansion, the gas resistant part, but it's not essential. The BME 280 for all intents and purposes is a pretty good module. And again, you can buy these aftermarket Amazon Grove pin port ones, the I2Cs, and they will work with the Wheel L1 tracker boards. And in some of the B-roll footage that you're probably seeing now is that you can see me working and putting these things together in the board and seeing exactly how it kind of runs. What's nice is once you activate the different various settings in the Meshtastic app, like for example, I have mine to show the telemetry data on the screen here, and it's doing exactly just that. I don't know if you can kind of see that on the camera there, but I have the update rate, which will update every minute if you're logged into the node via Bluetooth, and it'll show your temperature range, your humidity percentage, and air pressure on here. And then what I've also noticed is that sometimes when the nearby node transmits out weather telemetry, it'll populate the screen if you're within range. That's kind of interesting. It'll say I have a weather node outside, the hanging one that I made, and it gives me an update on the air quality also sometimes. So it overlays my telemetry data on the screen when it receives it. So that's kind of interesting that they programmed that into the Meshtastic firmware. Now with the companion app on the Meshcore, you don't get that on the screen because it's not really designed with that feature in mind necessarily. What it does do, you can access the data through the app on the phone, and if you have another companion node, you kind of see this data from this companion app. So it's a little bit different setup in terms of Meshcore. It's more geared primarily towards text communication, chatting basically, instead of just telemetry data. You can do telemetry data on here, so, but it's not as friendly as it is for Meshtastic, and that's one of the bonuses of Meshtastic over Meshcore, in my opinion, in this specific example. Meshcore is much better for chatting and texting, in my opinion, when you have the infrastructure in place. So we also have a couple other items here. These are the WIO tracker cards that I use, and one's Meshcore, one's Meshtastic, and they both have temperature sensors in them. So you can get telemetry data temperature-wise from these as well. They're built into it, which is kind of nice, so you don't have to worry about plugging any kind of stuff in to get data. So I decided to build a module. I'm going to get the case over here. So this is a sample case that I have. It's an extra one, and I use this exact box here. It's sort of like a roughly a little bit less than about maybe 2 3/4 inch all around square, and then maybe 3 on this end here. So 3 by 3 by 2 3/4 depth box. And what I did was I drilled a couple of holes in the back, 2 screw holes for mounting for structural integrity, and a gland port, which the BME 680 sits in the center of this box, and I put this up on the Mount Beacon node. So as you can see, it's pretty much covered with holes so it can breathe better, and it's got a breathing port on the top here I put, just so that the higher upper levels don't get water coming down onto the sensor, but a lot of the water vapor can get out at the top, and the heat especially. I tried to mount the sensor in the middle, and I covered the front with reflective paper and white type of material so that it doesn't get the sun on it directly, so it doesn't skew the heat. The BME 680 seems like it's doing a decent job when I compare it to, say, just an ambient temperature reading like this one here, and then a couple others. So I have like maybe 4 or 5 data points to compare it to. and they're all within like a degree or two of each other usually, especially with the humidity and things like that. So it kind of evens out. It's not going to be the exact measurement data that you need. So, but it won't be too off either sometimes. So it's always good to check your sensors. Now moving on to the BME 680, I have one in the pack here. You can kind of see it's this 6-pin one, but you only need 4 pins. Again, much like the BME 280, this one has an extra 6-pin for a different input-output arrangement, basically. But you're only going to use 4 pins, and again, that's going to be the positive, the ground, SCL, and SDA. The other ones you're not going to use, so you can like break off the pin headers there if you want to with pliers and just use a 4-pin configuration. And it's about roughly like another half size bigger than the BME 280 and a little bit longer. This little portion here, the silver portion, I don't know if you can see that in the bag, but that is the actual sensor. So what I did was, up in the node on Mount Beacon and also the new build that I have out in the front yard or the backyard now, is I put a bunch of silicone grease, silicone sealant, and I sealed up all the all the resistors and things on the PCB board and the pogo pins, or the not pogo pins, but the pins here, just the regular pins, so that they wouldn't corrode and get water condensation on it and maybe potentially short out the module. And that's kind of my way of weatherproofing the sensor. You got to avoid this little piece here, this top portion, because that's where all the data is. There's a lot of like items on that board that react to say the amount of metal stuff in the air, the electrical charge. It's very complicated, but basically it's your temperature, humidity, pressure, and air quality measurement in that little silver housing there. And it's got like these small solder joints and like a bunch of pin arrangements on either side to connect and get electricity to it. So it's very cool micro technology. You literally need a microscope to do this kind of stuff, and it's just amazing and fascinating that they managed to get all this on a little tiny board. So it's kind of cool how that works out. Now there's other sensors out there, the SHT line, and I have 2 examples here. I haven't tried the bigger one here, but I have tried a similar module, a SHT 4X, and that does work, and that's the one that's in here. It's similar to the BME 280 in size, but it doesn't provide air pressure, I believe. So I get humidity and temperature out of it, and it's fairly accurate. I don't know the exact specs off of it, but it does work in here. I was trying different types of sensors, and then I went on Amazon. I bought a couple of these. This is the SHT 31, and this unfortunately does not work with the Meshtastic type of interface. I did get the telemetry to pop up on screen, but I can never get it to transmit out with the SHT 31. Now I think it supports the SHT 30 modules, but the idea is the module is inside this waterproof or water resistant case, and it allows humidity and temperature to breathe into it. And you unscrew this ring here, and then you put this in between the wall and whatever it is you're mounting to the outside port. So it kind of bypasses this idea completely. And I have a bigger module here, which I decided to get off Amazon. It took a couple of weeks to get here, but this is the SHT 40 or the 40 or 4X, and it's even got the labeling on the side here. So again, same concept. You unscrew the what they call the, I forget what they call them. I just call them glands. That's it. It's similar to the glands, and you pretty much put this in between whatever it is you're trying to screw onto, and then you kind of cap this off, and this sticks on the outside. So very cool stuff in terms of build quality, and I don't know if it really truly works though, but they say it does. So I haven't tested these out yet, but then you also have these 4 I2C pins. You have the positive, the ground, what I think is the clock line, and the data line. So you can do that, and I look forward to testing this out on a Wheel Tracker L1 board. Unfortunately, all my stuff is being in field use right now, so I'm going to wait until I get another L1 board to test this out. But that's some other options that you could try to do. And I just want to talk about this briefly. I have a female, or rather male to male adapter on here. So if I unscrew this off, you really get this portion of the bulkhead adapter, or the panel mount adapter, if you will. This is an N1. It's not an Amphenol one. So you want to get probably an Amphenol one where you can solder directly to the plating. This one's nickel plated, so it doesn't take the solder very well, if at all, unless you have very high heat. So I have about 12 gauge solid copper wire. I stuck one in here, and I used part of the covering cap to kind of give it a little bit of strength relief, so if it moves, it kind of hits the cap and then kind of keeps it in place, if you will, and keeps some of the water off of it directly. But the more angular you bend these down, the more it kind of gets a better ohm impedance and SWR rating on the VNA. So this is very much spot on for both Meshtastic and Meshcore. And these are quarter wave ground plane antennas. I love making them. They're pretty cool looking. People seem to enjoy them. I have ring terminals like screws, and then I have the lock nut washers on it and the nuts on it to keep it secure from moving. You really need to have that to have these things secured, as I've experimented without using them and with using them, and it's just a little bit better experience overall. And then the one thing about these homemade antennas, you need the clearance from the bottom to really kind of keep these radials pointed down. So it works very well. I have them on the Nimham nodes, the Meshcore and the Meshtastic ones. Now I want to talk about the node I built, the dual node. So I do have let me find it here, an antenna my friend Steve gave me, and to put to good use on the hilltop, which we're going to do. This is a 3 dBi gain antenna. It's made for basically Meshtastic line or Meshcore, and it's got an end connector. So I have this on the node outside, and then I have a smaller fold antenna, which does measure up on the VNA, which is good for the Meshcore node. So I have a primary antenna and a secondary antenna, and I try to space them as far apart as possible, at least more than a quarter wavelength, and it's just not enough, I think. I don't think it's going to last long, but it's an experiment of having two of these exact things, these wheel tracker L1 boards inside. And what I did was I cut the Meshtastic one over here, a little port, and I'm running the sensor out, a BME 680 sensor like this, out into a little tic-tac box. And the tic-tac box is fits just exactly in it in a certain way, and it kind of shields it from getting rained on directly, and it allows air to breathe up into it and humidity and whatnot, and there's plenty of breathing holes. And more importantly, I'm able to mount that tic-tac box to the side of the actual box itself. So it was sort of like a last minute ad hoc adding. I was going to add something like this on the side, but it turned out to be a little bit too big for my liking, so I wanted to keep the dual node build to a smaller effect. Now, I've had it running for a couple days, and it seems like it's working okay. I've read various reports of people have these antennas, both Meshtastic and Meshcore, next to each other about this distance, and they claim that it doesn't seem to anecdotally affect it. I know it does affect it, but to what degree it does, I don't know. So I don't recommend you do this at home if you're going to build a dual node setup. You probably want to just separate them, not just on a horizontal plane like this, but you want to have one probably like far below it, so that it doesn't interfere with the radial patterns as much and they don't desense each other. Now, I also have a small soft filter on the Meshtastic one. I also got one that I think I might put in for the Meshcore node, because I think filtration is going to be a real thing soon with a lot of these things popping up, and you're going to need to have either a cavity filter. The soft filters are sort of like a band-aid on it, in my opinion. You really want to have a dedicated cavity filter that's going to really reject a lot of noise and potential interference on the band. So time will tell, and I might just reduce it down to a single node, either Meshtastic or Meshcore repeater type hanging node like my brother has. He has a single satellite node, as I like to call them, and we got one above the QTH here hanging on a line in free space, which is good for the sun and for the signals to get out. But it's been a fun project playing with a lot of these sensors and coming up with kind of like weather telemetry data sent wirelessly, not on the internet or reliant on the internet. That's the main thing here, and building these is a lot of fun. I don't have too much more else to say except give it a try yourself, see what you kind of find out with the Grove 2 port, or the Grove port rather, the I2C port, and experiment with it and let me know what you come up with. That's all I got to say. Thank you for watching and enjoy your day.